Okay, so now we will come to the topic resistance. So this is something we have known from the Ohm's law, that the constant that we have been constantly telling is the resistance. That means this is the factor which remains constant when your voltage is increasing and I is increasing consequently. Okay, so now we will come to the topic resistance. Now first of all, even if you don't know physics, but let's say if you don't know about this topic, it is from the literature sense we know that resistance, right? We are resisting. That means there is some obstruction. Now, if I say there's an obstruction, what do you mean by that? That means obstruction to the flow of electrons, right? Because no one else is moving or no one else is there in the full material that is moving, only the electrons are moving. So, if I say the obstruction that is offered, or you may say that is definitely not a good thing to offer the electrons, but anyways, obstruction that is led for the path of the electrons, where the electrons will definitely will encounter certain obstacles. So, that obstacles is known as resistance. Fine. Now obstruction offered to the flow of current. Okay, so in this case now it will be what? Now in this case definitely it will be the current is, again I am talking about, it is the concept, and who is flowing? That is electrons. So the obstruction that we offer it to the flow of electrons, or you can say the current itself, that is known as resistance. And how are we going to find out? We are going to find out the ratio between what? Between the potential difference, that's V, across the ends, and how much current is flowing. So this is something that we represent as resistance. That means that constant K is the resistance. So the SI unit of resistance is the surname itself, that's Ohm, and the symbol here is known as omega. Okay, fine. So now again the same thing. No, again we are going to define the one SI unit of the resistance. Okay, so now again this is something that you can also say, right? Now when I say that what is 1 ohm, that means it is a ratio between voltage and current. Then again which we are concerned with, yes, 1 ampere. That means if we want to find out what is if I want to say that my resistance is 1 ohm, that means my current is definitely 1 ampere. And my and what is my resistance? What they are saying that you have to tell this, that is 1 ohm. So 1 ohm and 1 ampere is there. That means definitely the voltage across the ends will be also 1 volt. So the ratio, or you can say resistance of 1 ohm is offered to the flow of electrons when the voltage across the ends is 1 volt and the current flowing is 1 ampere. Fine. So the ratio between 1 volt and 1 ampere is known as 1 ohm. So resistance, again and the topic comes, the resistance is the fundamental or derived? Yeah, it's derived. Fine. So derived, why? Because we are deriving from two further physical quantities. Hence it is a derived physical quantity. Fine. So this is a derived physical quantity, and okay, Ohm's law is applicable to both DC and AC, means direct current and alternating current. This is something that will follow in the next part of the chapter. Okay, so kind of if I'm trying to say, if you say that if resistor is, offering obstruction to the flow of electrons, then insulators, then what is the connection between different types of materials? Okay. So we know this much, that conductors are those substances which allow current. This much is clear, right? Conductors are those substances which allow current to pass through them very smoothly. Okay, that means the place, or you can say the road that is trodden is bit less crowded. That means there is not so much amount of people gathering out there, right? That means the electrons can easily move through them. That is the path of conductors. Okay. Now here comes an interesting question with resistors and insulators. Insulators are like those substances which will not allow only the current to pass. Okay, so because when I was defining what is insulator, I was saying which may or may not allow. So that is the reason I have kept one gap in that, so that I can say what is the resistor. So insulator is what? Who is offering infinite obstruction to the flow of electrons. Infinite means it is so congested that you need to take your vehicle to some other way. That is the meaning of insulator. That means current will not flow through insulator. That's the reason we can touch an electrical wire which is insulated with rubber or plastic or PVC, some fine, but we cannot. But if we touch one resistor, definitely we are going to get some part of electric current, because resistor says, yes, I do offer obstruction of the flow of current, but I do not omit the flow of current. Remember one thing. Insulator says, I will not allow only the current to pass through them. I will not let the electron flow through me. But resistors is saying, definitely I allow obstruction to the flow of current or the flow of the electrons, but I don't omit the flow of electrons. Electrons can pass through me. Okay, so in that case, resistors will be definitely, they will be having low resistance, high resistance. Okay, so this is what is the concept of resistor. So please understand, conductors, they allow very, very low, or you may say almost zero resistance. In resistors, the value can range. Okay, it has a range. It can vary, where it may have less amount of resistance, more amount. Anyways, 3 ohm is less resistance, 100 ohm is more resistance. Okay, but for insulators, it is what? Infinite resistance. I will not allow only the current to pass through them. That is the insulator. Okay, so next. So based on this, again, we can further classify materials. Previously, I have classified materials into conductors and insulators based on how we have also explained the energy gap between the valence band and the conduction band. So, but for resistor, you may say the valence band and the conduction band is almost near, not overlap, but it's almost near. Okay, so because of that, if you give one potential difference, external energy, definitely the electrons can flow. Okay, now conductors are those materials which have very low electrical resistance. Example, silver. Resistors have electrically very high resistance compared to conductors. So like nichrome. Nichrome is an alloy. Okay, and insulators have infinite resistance, which means it has huge amount of obstruction. It completely obstructs the flow of electron. As a result, current cannot flow through them. Okay, next. Okay, this is a very interesting question. If you see, you can try to solve it by yourself also by pausing. Okay, but let me go. A student plots VI graphs for 3 samples of nichrome wire. So first of all, you have to be very particular about question. If I say a student has plotted VI graphs for rubber, that means you have to say the question is wrong. Why? Because rubber is an insulator, right? Rubber is an insulator. It will not allow the current to pass through them. So how can you plot the chart? So you have to be very particular about this questions. Okay. So now see, this is nichrome wire. Okay. With resistance R1, R2 and R3, choose from the following statements that holds true for this graph. Okay. So my V is increasing and my I is increasing. This is something we know, and that's the reason we did not get anything. We missed the graph. We did not get any graph like this. We got a steep slope. Why we got a steep slope? Because we know that they are proportionality signs. They are directly proportional. Okay. Now the question comes here. You may see when V is increasing, just try to understand like this. When V is increasing, current is increasing like this, right? It is increasing like this. Okay. Now why for R2 means my current is increasing. Fine. So if we try to find out the slope, we will find out the slope. Okay. First. Next, when my V increasing, I is also increasing. When my V increasing, I is also increasing. Fine. So this is my current. For the current, we can say it's increasing in this way. Now, if you see one thing very carefully, when my voltage is increasing, in which of the following cases can you say that the current has increased to very like it has gone like the flow of current has not been obstructed much? Can you say, as my V is increasing, the current is increasing like this? That means if I'm considering the point here, this point, and almost this point, right? If I'm trying to jot it down. So you may say the values here, and the values here, right? So at this particular voltage, if you see for the 3 graph plotted, the current, let's say this is I, okay, that means I2, this is I1, and this is I3. Okay, so if you see this point, particular voltage, that means a particular value on the x-axis, if you try to jot the value from y-axis, you may see that I3 is greater than I1, then I2, right? If you see this at this particular point, okay, I'll just try to make it, I will try to make it a more colorful way. At this particular point, right, at this particular point, if you see against this particular voltage, let's say this is V general, from this particular voltage, you see I2 is here, I1, I3. That means for this current, if you say I3 is greater than I1, it's greater than I2. Now, we know if current is greater, if current is there, means high, that means obstruction offered to that flow of current is less. right? That means I3, if it's the case, that means R3 will be minimum, right? Because current is very smooth, the current has increased very nicely. That means my resistance will be what? Will be low. So for that reason, my R3 is the smallest. So if you see, my R3 will be the smallest, then my R1 and then my R2. So since my current, here you see they have tried a lot of effort to increase the voltage, but the current is increasing very slowly. That means R2 is the highest. Fine. So the option that will follow this is R2 is greater, R1 is greater, R3 is the, yeah. So option D. Fine. Did you understand this part? How will you try to solve this question? Even if, let's say, there are lots of lines, or maybe lots of plotting they have done. So what you will do particularly for a voltage, you just jot out that in which particular lines, where are the points that they're meeting. Okay, like for this particular point, okay, I'll just give you a revision, okay, so that you may understand this part and you can solve this graph-based questions very easily. Okay, see, I'll tell you. Let us pick this part. Okay, let us pick this part. Okay, I'll try to give a more brighter color so that you can understand. So this is my voltage. Let's say this is some value is there. Okay, some value is there voltage. Okay. Now, if I'm now against this voltage, what are the conditions of each and every line that they have plotted? So this is one point. This is the other point, and this is the other point, right? See, I have tried to make them in the same straight line. Okay. Now this is the x-axis, right? This is the x-axis, and we know this is the y-axis. Now for a particular value on x-axis, there are different values of y. Now you may say this is, let's say this is I1. Oh, not I1. Sorry, I2. This is I1, and this is I3, right? So in this case, you may see that for particular voltage, when they have all started together. For that particular voltage, you may see I3 is the greatest, means the highest current it has reached. That means in this path only, means in this particular circuit only, the obstruction that has been offered to the flow of electrons is minimum. For that reason, my R3 is, the resistance is minimum. So here among these three, R3 is a minimum. Okay, then we can easily understand from here also. That's I1. Next means it's greater than R3 but less than R2, and R2 is the largest. This is how you need to understand something, means understand the resistance from the graph. Okay. Next question. This is an assertion reason kind of question. The metals and alloys are good conductors of electricity. Bronze is an alloy of copper and tin, and is not good conductor of electricity. Now you may, if I see this, that is this assertion is correct. Okay. Assertion is what? Correct. And if you see it's an alloy of copper and tin, copper is a metal, tin is also metal. So they are, both of them are good conductors of electricity. But what they have told is this is not. That means reason is false. Okay. That means the reason is false. So assertion is true, but R is false. We'll go with C. Okay. Oh, this is a pink color, right? This one. Means I'm talking about this one. That is A is true, means assertion is correct, but the reason is false. Okay, next question. This is easy. A potential difference of 20 volts is applied across the ends of a resistor of 5 ohms. What current will it flow? What current will it flow in the resistance? Okay. So V is equal to 20 volts. Okay, V is equal to 20 volts, and R is equal to 5 ohms. Now what they have asked current. Okay, so we know that, before doing this, I'll just say, so V is directly proportional to I. I'll not do here. Okay. V is directly proportional to I. That means that there's a constant. I mean to say, first only I'll not write the constant. V is equals to K and I, right? So this K is no other than resistance. So that means my potential is the product of resistance and current. Okay. So V is equal to IR, and we need to find out I. So it's V by R. So V is 20 and resistance is 5. So it becomes by 4 ampere. This is very easy and pretty good. Okay. Next question. A resistance of 20 ohms have a current of 2 amperes flowing through it. What is the potential difference? That means this is just playing around with the 3 variables. Okay. So V equals to IR. What they are asking? They are asking potential difference. So just the straight product I is how much? 2 ampere. resistance is 20. That makes 40 volts. Anything else? Easy. Okay, next question. A current of 5 amperes flows through a wire whose ends are at the potential difference of 3 volts. Calculate the resistance of the wire. Okay, so I'll just go with it. 5 ampere through a wire whose ends are the potential difference. So the potential difference is 3 volts. So if first question I've tried to find out how much amount of current is there. Next question we have found out what is the amount of voltage, which we have tried to calculate the voltage. And this question they're asking to find out resistance. So V by I, right? So there is 3 by 5. That means it will be 0.6. Okay. So what will be my resistance? 0.6 ohm. Fine. Understood? This is this much. Okay, so that's all. This is just playing around with the 3 variables. Okay, next question. When a 12-volt battery is connected across an unknown resistor, there is a current. Okay, first of all, I'll just figure out my voltage is equal to 12 volt. Now, it's connected across an unknown resistor. That means we don't know what is the resistor. And there is a current that is flowing off. Okay, here you have to understand a thing very nicely, that when there was a question, right? 1 megavolt, something was there, no? In some question. 1 megavolt, 1 mega. No, that can be mega, ampere, mega, anything. Mega means 10 to the power 6. But if I write like this, remember one, this is the capital M and this is the small m, okay? When I'm writing here small, that means it is 10 to the power minus 3. That is, it is millivolt. Okay, milli. The prefix that we use in this case is milli. Okay, so voltage is how much? 12 volt, and current is 2.5 milliampere. That means if I want to convert this one into SI unit of current, that means it's 2.5 into 10 to the power minus 3 ampere. Okay, next, calculate the value of the resistance. That means R is equal to V by I. Fine. So what's my voltage? 12. What's my current? 2.5 into 10 to the power minus 3. So 10 to the minus 3 will go up, and down here it will be 25. Append another 0 because I will eliminate this 0. Okay. So 25 fours are 100. So more 2 zeros will be there. So 12 fours are how much? 48. 48, and there will be more 2 zeros. Okay. So this is what? Ohm. Fine. Okay. So resistance is the ratio between voltage and this current, and this is how you need to find out. So did you understand? You can imagine this much amount of volt. See, this is very easy, right? Means we can even easily understand also. This is the voltage. How much voltage? 12 voltage. And what is the current going through that? Is 2.5 milliampere. That means resistance is huge, right? So first of all, convert the milliampere into 10 to the minus 3 ampere, means into, just cross it out. And then resistance means V by I. You are good, you're way to go, good to go, right? So 2.5 into 10 to the minus 3 goes up, that means 1000. And because of 5, eliminating the decimal, I have appended another 0. That means total 10,000, 25, 400 is 10,000. Then 4 into 12 is 48, and append the 2 zeros, that makes 4800 ohm. Thank you guys for watching this video. If you really find this videos informative and helpful, please do subscribe my channel, Vigyan Jyoti. Hit the like button and share it with your dear and near ones. And yes, please don't forget to comment, because your feedback does matter.